Hi, this session is on dividing surds. Now, just to recap, the rule is if you are dividing two surds, so here we've got the square root of A and the square root of B, and they could be numbers. So we'll just put numbers in if it helps you to it makes more sense for you. Over 6, just say. Okay. What this is saying is the rule is if they're both surds or both under the square root, you can actually combine them to be one fraction. And the whole point of this is, if I take these numbers 2 and 6 as a fraction, well, what can I do with this fraction? I can simplify it. I divide the top by 2 and the bottom by 2. We know how to simplify fractions. And we end up with 1 over 3, or a third. And we can get this same result when we have surds. It's just that we still have to keep the square root in our first step. So using that rule, I'll combine 2 and 6, or 2 over 6, and this leaves me with, what do we get here? A third. But they're under the square root still. The square root symbol hasn't disappeared. And you can leave your answer like that because you have simplified, but you can actually go a step further. And then what you can do is then put them back under their own square root. So we have the square root of 1 over the square root of 3. So I'll put them back in their own square root. And we know that the square root of 1 is just 1, because 1 times 1 is 1. So our final answer would be 1 over the square root of 3. And that's it. Now, you don't actually have to show this step if you don't want to, where you combine the numbers into one fraction or under the one square root. But it's just there for you to understand that when simplifying surds, we can actually do this. So what I mean by that is 2 and 6, I could have gone like this. Divided by 2 is 1, divided by 2 is 3, and I have my 1 over 3 without doing this extra step. Now, if you want to, have a go at these questions yourself, and then if you get stuck, just watch what I do. So with the first one, we've got 72, and then square root of 72 over the square root of 8. Technically, if you wanted to, you could try and simplify this surd, the 72, and simplify the 8 if you wanted to. But because we know that we can simplify them as they are, because they're both under the square root, let's do that. So, is there a factor of 72 and 8? Well, I know that 72 divided by 8 is actually 9. Or if I divide the 8 by 8, I get a 1, and 72 divided by 8 is 9. So I'm left with the square root of 9 over the square root of 1. The square root of 1 is just 1, so just a whole number 1, which will be invisible. So we're left with the square root of 9, and that's it. And of course, the square root of 9, we know 9 is a perfect square, so we end up with a whole number 3. And it's much easier to do it that way than trying to simplify the surds individually. For example, what I meant by that was the square root of 8, I can simplify the square root of 8 as 4 times 2, and then the square root of 4 is 2, and I have 2 square root 2. And you could have gone and done it that way, but you can see how it's more working out, and this was a lot easier. All right, with the second one, we can see that we have the division symbol, so we're dividing these two, and we know we can rewrite this as a fraction. It's always easier to have it in fraction form. Now don't forget there's a negative here, so we've got a positive divided by a negative. So the whole thing will be a negative, so that can just sit in the middle because it's saying the whole number is negative, and square root of 54 over the square root of 2. So now let's simplify 54 and 2. So I know that the rule says we can combine it, but I can skip that step and just ignore the square root, basically. So 54 divided by 2, we know our answer will be negative because there's one negative. And what's half of 54? Well, it's 27. But don't forget, it's under the square root still. Okay? Now, if you stop there, you have divided your numbers or your surds, but you haven't finished simplifying. Now, is there a perfect square that's a factor of 27? We know our perfect squares start from 1, and we've got 4, and we've got 9, and so on. And I know that 9 can we can divide 9 into 27. So we end up with, instead of the square root of 27, we can have 9 times 3. And because 9 is a perfect square, the square root of 9 is 3. So we end up with 3 square root of 3. And that would be our final answer. We cannot simplify this any further. If you stopped here, you wouldn't get full marks, basically, because if you've learned how to simplify surds, you're expected to know to go further. Now with this one, there's actually more than one way of approaching this type of question. And sometimes when you simplify surds and fractions, you actually can end up with a different looking answer, but it's actually the same decimal. So just say you're working in your textbook and you've done the right thing, but it's not matching with what the textbook has. Put it in your calculator, your answer, and see if you get the same decimal as what's in the textbook. Now with this one, we can actually do this two ways. Now I'm going to do the first way that I'll do it is actually the best way and the fastest way, because I'm using my knowledge of fractions and simplifying fractions as well. Now we know that when we are multiplying any number, variable, or surd, and there's multiplication in between everything, so we know there's times there and times there, everything on top and bottom is being multiplied, you can basically simplify anything on the top and on the bottom, as long as there's multiplication in between everything. If there was a plus here, then you couldn't do it. Just keep that in mind. So there's multiplication everywhere. So now what I'm going to do is start simplifying. So let's see, I've got well, I'll start with my numbers on the outside. So I've got 5 out here and 4 out there and 10 out there. So remember, if you've got numbers on the outside, they can be simplified together, but numbers under the square root are simplified together. So 5 and 10 can be simplified. 5 divided by 5 is 1, 10 divided by 5 is 2. Now, I've also got a 4 up here and a 2 down here now. That can be simplified. 2 is gone. 4 divided by 2 is 2. So let's see what I've got left. I've got 1 times the square root of 2, which is just the square root of 2, times 2 square root of 12, over, that was just a 1 out here, so the square root of 8. So I've taken care of my outside numbers. Now I'll simplify what I can under the square root, numbers under the square root. So I've got 2, 8, and 12. So if I wanted to, you can simplify the 12 and 8 or the 2 and 8. So you just pick a number. I'll pick the 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. Okay. And then I can also see that the square root of 4 is actually 2. So I'm going to cross this whole thing and I'm left with a whole number 2. Okay, and let's see what I've got left. So I've got, this is just the square root of 1, and of course, I'll write it out here so we can see. So the square root of 1 times 2 square root of 12 over 2. Now, our next step is, well, the square root of 1 is just 1. 2 and 2 are both whole numbers, both on the outside. So that can go and that can go. And so what am I left with? That's just the 1 down there. I am left with, well, 1 times the square root of 12 is the square root of 12 over 1, which leaves me with the square root of 12. So after all what we started off with, I'm almost done. I now have the square root of 12. But are we finished? No, we're not, because we know we can simplify the square root of 12. So I'll put my square root of 12 up here. Now I know a perfect square that's a factor of 12 is 4. So 4 times 3 gives me 12. So the square root of 4 is just 2, square root, and the 3 stays there. And that would be our final answer. Okay? So we approached this by first simplifying what we could. And the other way of doing this, so I'll write the question again. Now you could have approached this by not simplifying first, and when you don't simplify fractions first, it can get harder. But let's have a look. So what I meant by that was I can go 5 times a 4, multiply numbers on the outside, which gives me 20. Square root 2 times 12 is 24 over, And on the bottom, there's nothing for me to multiply, so I have 10 square root of 8. Now, this one may not take us as long, but sometimes other examples it can take you longer, depending on how large your numbers are. So now let's simplify what we can. So 20 and 10, well, 10 divided by 10 is 1. 20 divided by 10 is 2. And that's my outside numbers done. Inside, yes, you can simplify them individually, like the square root of 24 and the square root of 8. But knowing our division rule with surds, I know 24 divided by 8 is just 3. Or 8 divided by 8 is 1. And 24 divided by 8 is 3. So I'm left with 2 square root of 3 over 1. And that 1 can become invisible. So we end up with 2 square root of 3. Okay, and we still got the same answer as what we had before. So in this case, there were 2 ways we could have approached this. But it's good to remember that when you have fractions, try and simplify what you can first when you're multiplying. Now let's try a question from your worksheet, your revision worksheet. So this one here, once again, simplify numbers on the outside and then simplify numbers on the inside. 12 divided by 3 I know is 4, or 3 divided by 3 is 1. 12 divided by 3 is 4, so 4 stays on top. And I have 108 and 12. Well, I can divide them both by 12. 12 divided by 12 is 1. 108 divided by 12 is 9. So I end up with the square root of 9 on top. And then 1 times 1, we've got the square root of 1 on the bottom. And because 1 times the square root of 1. Now, of course, we know the square root of 1 is just 1. So I didn't have to even write that. And the 1 can be invisible on the bottom. So we're left with 4 square root of 9. Now, are we finished? No, we know 9 is a perfect square. The square root of 9 is 3. So I will have 4 times 3. And 4 times 3 is just 12. And that's our final answer. This last question that we'll be doing for this session also came from your revision sheet. And let's have a look and see what we have. So we're multiplying all of these fractions that have numbers, rational numbers, but also surds. So the best thing to do is simplify before you multiply. It's much better to do that and then going, for example, 7 times a 5 times a 9. We end up with large numbers and it's harder for us to simplify. So let's work with our outside numbers first and see what we can simplify. Straight away, I see a 3 here and a 3 there. Gone. Just a 1. Now, I've got an 8. Oh, sorry. This is supposed to be the square root of 8. Sorry. Just to make sure it's like your worksheet. So just fix that up. So now I've got 12 out here and a 2 out there. They're both even. So divided by 2 there is just 1. 12 divided by 2 is 6. And I'm left with no other numbers on the outside. So let's rewrite what we have so it doesn't look too messy. So I have 6 square root of 7 over the square root of 5 times the square root of 5 over the square root of 8 times the square root of 9 over the square root of 7. Now our next step is to work with our surds, the numbers under the square root or the radical sign. So let's just simplify what we can, basically. And straight away, I've got a 5 there and a 5 there. Gone. The same number divided by 5 is just 1. So it's just 1. I noticed that I've got also down here the square root of 7 and over here the square root of 7. Remember, you can simplify anything from the bottom and the top. Even though it's all the way across here, I can still simplify this 7 and that 7. As long as it's from the bottom and the top. Just keep that in mind. So that's also a 1. So now I can't really simplify anything else because 8 and 9 won't simplify. So because it's looking messy, let's just write down what we have. So I've got 6 times 1 times the square root of 9, which leaves me with 6 square root of 9 over, I've got 1 times the square root of 8 times 1, so I'm left with the square root of 8. Now, never just stop and think, oh yeah, I'm finished. Always double check and see what else you can do. And I can see that well, I can't simplify 6 and 8. Be careful if you thought that. Is 6 under the square root? No. So we cannot simplify 6 and 8. But the square root of 9, I know 9 is a perfect square. Square root of 9 is just 3. So I've got 6 times 3. 6 times 3 is 18 over the square root of 8. So I'm almost there. Just say you stopped here, you have done a great job. But there's one more thing you can actually do. And have a look. The square root of 8 can also be simplified. So let's make some more space at the top. So I have 18 over the square root of 8. So the square root of 8, I'll just do the working out here. You might be able to do it sort of mentally and just see the answer. But let's just do some working out. So square root of 8 can be written as 4 times 2, because I know 4 is a perfect square. So square root of 4 is 2, and I'm left with the square root of 2. So the square root of 8, when simplified, is that. So we have 18 over 2 square root of 2. And finally, this should be our final step. I can now simplify the 18 and the 2. 2 divided by 2 is 1. 18 divided by 2 is 9. So my final answer is 9 over the square root of 2. So this one was sort of a long one. But remember, whenever you're multiplying, whether with algebra or surds or numbers, always simplify before you multiply. Thank you.